Heat transfer is the flow of energy that moves between two objects. Heat is a form of energy, actually, and it is dependent on temperature and also a medium. A medium is just the object or property that the heat is being transferred through. There are three types of heat transfer: conduction, convection, and radiation. Radiation is the only form of heat transfer that does not require a medium in order to transfer heat, which I'll explain later. It should also be noted that heat is transferred from warmer regions to cooler regions. So first I'll discuss the method of heat transfer is conduction. I'm mentioning this one first because it is the most efficient and because the next method I'll discuss actually depends on conduction. Conduction is the most efficient because heat is being directly transferred through physical contact. This mostly occurs in solids because the objects will need to actually physically touch in order to transfer heat this way. In the photo of the coffee cup, the hot coffee touches the spoon and it is directly heated through physical contact. Another common example is a heating pan, or heating a pan. The pan comes in direct contact with the burner and passes heat. You would also feel conduction when you hug somebody that's warm. If you come from outside and it's really cold, you go and hug somebody, you are transferring heat through conduction to warm yourself up. More examples of conduction include picking up a cold penny. Conduction would occur as your warm hand comes in contact with the cooler object. Heat moves from a higher region to a lower, cooler region, like I mentioned just a second ago. So you would also experience conduction when you turn on your car. As the engine begins to heat up, you would feel the hood get hot. This will especially happen after you drive it. When you turn your car off, you go and touch the hood, and it is definitely going to feel warm. Now, I already mentioned the hot pan example, so in this case, the warmer object would be the pan, which would actually have more kinetic energy in the pan because the temperature is a lot higher. These particles vibrate towards the cooler particles in your hand, and that's how heat is transferred. So on the opposite side of conduction, which is an efficient way to transfer heat, we can talk about insulators. Insulators do not transfer heat well. They are not efficient, which is good in some cases. I mentioned earlier that some products are made to be good conductors of heat and others are made to insulate and keep heat trapped in. Some materials like silver, gold, and copper are good conductors of heat. Thermal insulators prevent heat transfer by restricting flow of molecules. Glass, styrofoam, and wool are great insulators. This is why winter jackets are often made of wool or down feathers, and why Chick-fil-A cups or other to-go cups that you would find at a restaurant are made of styrofoam. This is a little bit more easier than handing somebody a glass to-go cup, so it's just a different way to prevent heat transfer. Next heat transfer is convection. Convection is the transfer of heat most often through liquid and gases. It is still efficient, but comes in second to conduction. So think of convection as a conveyor belt system. Warm air expands and circulates to the top, pushing cold air to the bottom in a circular motion. Cool air is more dense, so it sinks. Firefighters crawl low to the ground because cool air sinks to the bottom of the room, pushing cool air, which pushes cool air to the bottom. As the circle continues, cool air will be pushed towards the heat source, and the particles will become excited and heat up. And as they heat up, they will gain heat, expand, and rise to the top. So in the photo, you would see the cool air is circulating to the bottom, but as it's pushed more towards the burning sofa or chair, I guess that is, the air heats up and gets excited and moves to the top in a circle, and then as it loses heat and is being moved away from the heat source, it goes back down and sinks, becomes more dense, and the cycle just continues to repeat itself. Other examples of convection that you would experience day to day can range from space heaters that you would use during the winter time to convection ovens in restaurants and even boiling water. When you boil water, you need conduction as well. This is why they're dependent on each other. The burner physically touches the pan and transfers heat. That's conduction. And secondly, The pan heats up heats up to transfer heat to the water. Space heaters have a motor unit inside of them that sucks cool air in and then releases warm air into the room. Space heaters provide a more gradual increase in temperature, so it's not as efficient, but it still works. Another cooking example that uses convection are convection ovens. I work at Starbucks and we use convection ovens to heat our food, our pastries. The oven is a small confined area and it circulates the warm air, blows the warm air around the cavity to heat up the food. The last type of heat transfer is radiation, which occurs through electromagnetic waves. Since radiation travels through waves, there doesn't need to be any physical contact or actual matter to pass through, so that makes it a little bit less efficient. During radiation, different radiation waves can be harmful to humans. The sun is the most well-known example of radiation, and the effects can cause early aging and also skin cancer. Different rays from the sun have different effects on the skin, which I'll discuss different waves in the next slide. So the sun transfers heat through radiation in the form of waves, also known as ultraviolet waves, and you would abbreviate those as UVB and UVA waves. Radiation doesn't need a medium, like I mentioned earlier, to travel through to transfer heat, so that's why it can travel through space, because there's not any matter in space. The sun emits the radiation waves and they travel to Earth. So when you buy sunscreen, bottles will often advertise as broad spectrum protection, and what this means is that they can protect against UVB and UVA rays, which cause sunburn and premature aging, respectively. These rays combined can cause skin cancer as well, and surprisingly, even though radiation is harmful to the body, it can also be used to kill cancer cells. And while this is beneficial in medicine, it does increase the risk for a second cancer. So that's kind of the downfall of it. But most of the time, the pros outweigh the cons. Other common examples of radiation that we experience daily are X-rays, microwaves, and the waves that are emitted from the radio whenever you listen to your music. So overall, whenever you buy a sunscreen, it's good to make sure that the bottle advertises as broad spectrum protection. So going back to sunscreen, I think it's important to explain exactly how these products help protect us from the radiation. UVB rays, which cause sunburn and penetrate to the more superficial layer of the skin. UVA rays, on the other hand, penetrate deeper down through the actual dermis, which is a more deeper layer of the skin. Heat transfer occurs when an object absorbs heat from another medium or surface. So in this case, the sunscreen blocks the absorption of the rays, protecting you from sunburn. Rays of the sun are also called ultraviolet rays, and different SPFs and sunscreen will defend more against the rays. So you'd see SPF 5 is not going to be as effective or protective as the sunscreen that advertises as SPF 50. So in the photo you can just see the skin absorbing the radiation without skin protection. The UVBs penetrate through the epidermis. The UVAs penetrate all the way through the epidermis, through the dermis, and even down into the hypodermis. And then the next picture on the right, you see the UVA and UVB rays being reflected off of the skin. And it only lasts for a few hours, so it's important to reapply sunscreen, especially if you've been in the water. The next slide. Radiation is one of the common treatments of cancer along with chemotherapy. My mom actually had skin cancer, but they did not use radiation therapy on her. She had chemo. So radiation is still harmful during this therapy, but since cancer spreads through rapid multiplication of cells, the radiation will target and destroy the DNA of the cells to keep them from multiplying and preventing the cancer from metastasizing. So in this therapy, most people are willing to take the risk, especially if their cancer is pretty severe. The chances of them getting a second cancer aren't as fearful. They're not as scared to do this therapy because it's going to help kill their current cancer. So in summary, Convection and conduction are a little bit more closely related. These heat transfers both need a medium. Radiation is a kind of the oddball out in this case because it doesn't need matter to transfer heat through, like I mentioned. However, conduction and radiation most often occur in solids, while convection transfers heat through liquids and gases. In this photo, you can see how all of these transfers kind of work together. In one system, conduction and convection work to heat the water. Conduction happens through the physical contact from the burner to the pan, and as the pan heats up, it uses convection to heat the water, causing it to boil. And then as the burner heats up, it emits radiation, and you actually physically can see the burner turn red. Heat transfer is always occurring to reach equilibrium, just as the body is always working to maintain homeostasis.